So let's talk a little bit about what you're going to be doing in your DC motors lab today. This is the circuit that is going to be used to drive the motor, and it's the first time that we've encountered this transistor right here. A transistor is an element that has three leads, three terminals. The first one over here on the left is known as the base, and then we have the collector, and then we have the emitter. The thing to know about a transistor in its switching orientation, which is what we're using here today, is that if a sufficiently high current is pushed into the base, then that means that we're going to be allowed to have current flow pretty much smoothly between the collector and the emitter. So it's going to be as though we're almost pushing a button over here on the left, and that's going to make a connection between the top and bottom pins over here. So as we're pushing this button, what that really means is we're going to send 5 volts out of pin 9 based on the selection of a 330 ohm resistor, the details of which you don't need to worry about right now. We'll be having sufficient current then to allow current to flow from top to bottom. Now as that happens, then current is going to flow from 5 volts through the DC motor and down through the transistor down to the ground connection. And so we're going to see that current is going to constantly be flowing, and when we turn off this voltage, now no current is going to be allowed to flow between the collector and the emitter, and all of a sudden now there will be no place for this current to go. It can't go any further, so it's going to stop flowing through the DC motor. Now the DC motor is a coil. It's composed of a couple coils of wire, and so what that means is that a coil of wire doesn't like to instantaneously change its current. This means that the current has to have somewhere to go. If it doesn't have anywhere to go, then a very, very high amount of voltage will develop across this motor, which could potentially damage the motor, it could potentially damage the transistor, or it could even damage the power supply. So what we're going to do is we're going to add this diode over here. And this diode is going to allow the current that is currently flowing through this motor to have a place to go. It's going to come up here and it's going to flow back through the diode. And it's going to in fact go around this loop until slowly over the period of, over a few milliseconds, the motor will dissipate the energy that it contained, and that's going to allow the motor to turn itself off without damaging itself or the transistor. Remember that the diode has to be pointing upwards because as the current is flowing down through the motor, it has to have somewhere to go, and it has to go in this direction. So we have to have a flyback diode that's going to allow the current to go back in the direction that it was coming. So that's the most important thing to know about the way in which the circuit is going to be built. Let's look a little bit at our first program here. You'll notice that we're going to use pin number 9, and we're going to set pin number 9 up to be an output. We're going to turn pin number 9 on for 3 seconds, so the on time is 3 seconds, and the off time is also going to be 3 seconds. So we're going to turn it on for 3 seconds, we're going to turn it off for 3 seconds. And as I turn this on, I know you can't see the board, but you'll be able to hear the motor as it turns on and off. So the motor is turning on and off for 3 seconds at a time. Now the second program is going to use this analog write. Now analog write is going to allegedly deliver a continuous voltage. It's not just going to have to be 0 volts or 5 volts, but it can be any value in between 0 volts and 5 volts. I say allegedly because in reality it can only deliver 0 volts and 5 volts. But what we're going to find then is that we're going to be sending it 0 volts for half the time, for example, and 5 volts for half the time. This is going to effectively give it 2.5 volt average. Or if we send it 0 volts 25% of the time and 5 volts 75% of the time, then we get 3.75 volts for the average. Or if we send it 0 volts 75% of the time and 5 volts 25% of the time, we get 1.25 volts. So what happens is we're going to switch the voltage on and off so quickly that the motor can't really start and stop. It's going to have, the change is going to happen so quickly, maybe 50 times per second, for example, that it's going to see this average value. And that means that we're going to effectively have a continuous voltage. In reality, it's not a continuous voltage, but in practice, in effect, it behaves as though it is a continuous voltage. So what we can hear here is that the the motor is going to switch between 2 different speeds. And so it's going between a low speed and a high speed. Now over here we have not only the ability to adjust the speed between 2 values, but we're going to accelerate between 2 values and we're going to decelerate. So this will cause the motor to continuously accelerate from its lowest speed up to its highest speed and then back down to its lowest speed again. So you can hear that in the way that the motor is actually turning. And then in the fourth program, we're going to have the opportunity to interactively control the motor speed. So I'm going to upload this program. And then once the program is uploaded, the motor is going to stop. And it won't do anything until I go to Tools, and then I go to Serial Monitor. Once I do that, now I'm in this window. And this program is not running on my PC. This program is running on the Arduino board. So this text right here came from the Arduino, went over the USB cable, and then it appeared here in the serial monitor. Now I can type any number, and notice that I have to type it in this little window, this little tiny bar up here at the top. So I'm going to type 255. That's the maximum speed. And as soon as I type that, it goes up to maximum speed. Now this should actually say between 50 and 255 because you do not want to go all the way down to 0. You want to only go as low as 50 because if you go lower than 50, it's possible you won't have enough energy to overcome the internal friction of the motor. And if you do that, you could cause a great deal of current to flow, and it could damage the transistor. So in your version of the program, it will not be able to go any lower than 50. And now you can hear that the motor has adjusted its speed. I'll be quiet here and type in a few values so you can see as it adjusts. So we now have the ability not only to adjust the speed of the motor, but this gives us now the opportunity to have a keyboard interface, this sort of keyboard interface that's going to allow us to communicate between the keyboard and the monitor directly to the Arduino board. And that'll be an application that's not only valuable today, but in future labs, it'll also be valuable to us in the future as you're perhaps working on your final design project for this class.